All right, I want to look at the definition of the 6 trig functions here. So I'm going to draw myself a right triangle. And I'm going to get this thing to sit still. I'm going to focus on this angle right here. I'll call it theta. We quite often use Greek letters for angles, mainly because the European tradition of mathematics came from a lot from the Greeks anyway. So here's my right angle over here. There's the angle that I'm thinking about. Of course, in a right triangle, the hypotenuse is over there. Whoops. The side opposite the angle is the opposite side, and since I'm talking about this angle, the side close to it here is the adjacent side. So adjacent. Now, I'm going to define 6 functions. The first one is called the sine, and I abbreviate it SIN, and the input is the angle. And the output is a ratio of sides. I'm going to grab the opposite side, the length of the opposite side, divided by the length of the hypotenuse. Next, I'm going to define the cosine. Let's put a line through here. The cosine, which is abbreviated COS, and the input is an angle. Right? This is function notation. This is the name of the function. This is the input. So you put in the angle, and you get out a ratio of sides. You get the adjacent side divided by the hypotenuse. Next is the tangent. The tangent is abbreviated TAN, and again, the input is an angle. And the tangent is going to be, so I've used this pair, I've used that pair, now I'm going to use the other pair, the opposite over the adjacent. So with those 3 trig functions, I've used all 3 pairs of all 3 possible pairs of sides, but I have other ways that I could use them. I could take each of those fractions and flip them upside down, and we get the other 3 trig functions to make 6 total. The next one I'm going to write is called the cotangent. Cotangent, it's abbreviated COT. The input is the angle. The output is the reciprocal of the tangent, so ADJ divided by the adjacent side divided by the opposite. Next, I'll do the secant, which is SEC. The input is the angle, and I'll use the same 2 sides as the cosine, but flip them upside down here. So this is the hypotenuse divided by the adjacent. And lastly, I have the cosecant. Whoops, let's actually write that out. Cosecant. It's abbreviated CSC. The input is an angle, and it's the same 2 sides as the sine, but flipped upside down. Hypotenuse divided by the opposite side. So there you have the definitions of the trig functions of this angle over here. Opposite divided by hypotenuse. Sine was the sine. Cosine is adjacent divided by hypotenuse, and so on. Okay. Now, sometimes it looks a little differently. That's the way the definitions are usually written. Sometimes we will have it looking more like this. Let's say triangles ABC. I'll make C the right angle. And I'm going to use capital letters for the angles, and I'm going to use lowercase letters for the sides. It's kind of hard to tell the difference between my capital C's and my lowercase c's if I make the capital C's too small. So I just made that a little bigger. There's a lower c. So the side opposite A will be little a. The side opposite B will be little b, and opposite C is little c. And so I have 2 angles here that are not the right angles. I'm not going to do this with a right angle yet. Eventually we'll talk about trig functions of right angles, but right now I'm going to focus on these other 2 angles. I want to look at what's the sine of angle A. Oh, a little bit of notation here. Let me just kind of off to the side here say, generally function notation uses parentheses, and you input. The input is what goes inside the parentheses. What's outside is the name of the function, right? With trig functions, it's not uncommon in fact, it is common that we forget about the parentheses, that we just write this as sine A. We should keep in mind that this is still function notation. This is not multiplication. You're not multiplying the sine times A. You are taking the angle A and putting it into the sine function and getting out a ratio of sides. Well, what's the ratio of sides? Sine was opposite over hypotenuse. So as I'm right here, sine is the opposite over hypotenuse. It's side A divided by little side C. What's the cosine of angle A? Well, up above our definition was the cosine is the adjacent divided by hypotenuse. So that would be little b divided by c. What is the tangent of angle A? The tangent of angle A is the opposite divided by adjacent. So that's A divided by B. The cotangent of angle A. Cotangent of angle A, I'm thinking back up here, what was cotangent? Adjacent divided by opposite. So the adjacent side divided by the opposite, that's B divided by A. What's the secant of angle A? Secant was hypotenuse divided by adjacent. Hypotenuse divided by adjacent, so C divided by B. And the cosecant of angle A is hypotenuse divided by opposite. So to begin with, you're going to have to be looking back at what two sides you want. The hope is that over a short amount of time we get so that you don't really have to think too hard about what two sides you need. In fact, if you do the triangle assignment coming up and the discussion afterwards, the hope is you will get so that you really don't need to think at all about what two sides you need. When you think a trig function, you know what two sides to grab. Right? Now, one thing I want to do here is that I've looked at the 6 trig functions for this angle A. There's also this angle B up there, which I can look at that. I want to know what is the sine of angle B. I want to know what is the cosine of angle B. I want to know what is the tangent of angle B, and so on. Let's do those 3 first. The sine of angle B. Sine, remember, is defined as opposite divided by hypotenuse. So for angle B, I want its opposite side divided by the hypotenuse. So this is now B divided by C. Likewise, the cosine of B is the adjacent side divided by the hypotenuse. Well, the adjacent side for angle B is this one, is angle A. So A is opposite, side A here is opposite angle A, but it's adjacent to angle B. So when I'm talking about the cosine of B, I want the adjacent side divided by the hypotenuse, A divided by C. Either way, C is the hypotenuse, right? But adjacent and opposite swapped roles when I swapped which angle I was looking at. Tangent is the opposite side divided by the adjacent, and this is opposite of B divided by the adjacent to B, and so on. Cotangent of B would be the adjacent side divided by the opposite side. Again, I'm focusing on angle B, so this is adjacent and this is opposite. And likewise, there's 2 more. Let's do them here. The secant of angle B is secant of angle B. Secant is, I'm thinking up here, secant is hypotenuse over adjacent. Hypotenuse over adjacent, right? That's the angle. This is the adjacent side. So C divided by A. And likewise, the cosecant must be the hypotenuse divided by the opposite side. Again, opposite to B now. Right? So C divided by B. Okay. One more thing I want to show you, and that is really, I'm writing these as fractions, but these are lengths of sides. So, and I'm just really giving the names of the sides. Technically, we should be looking at numbers. So let me give you one example where I actually have some numbers involved here. So here's a triangle. It turns out that 5 and 12, if those are the 2 short sides of a right triangle, you can figure out that the long side would be the square. Well, take 5 and square it, 25. Take 12 and square it, 144. So 144 and 25 is 139. Square root turns out to be exactly 13. Right? So if I look at this angle right here, I can say, what are the 6 trig functions of that angle? Well, the sine of that angle is the opposite side divided by the hypotenuse. The opposite side is 5. The hypotenuse is 13. Now see, you're actually getting a number here, 5 divided by 13. Right? The cosine of that angle is the adjacent side divided by the hypotenuse. So 12 divided by 13. The tangent of that angle is the tangent. If you can't remember, don't be afraid to look back up here and say, what was tangent? Tangent was opposite divided by adjacent. Okay, I mean, I can remember, but pretend I can't for a little bit. Opposite divided by adjacent, right? This angle, opposite side. This angle, adjacent side. Okay, so 5 divided by 12. Tangent, cotangent of the angle is the adjacent divided by the opposite side. The secant of the angle is the hypotenuse divided by the adjacent side. And lastly, the cosecant of the angle is the adjacent, no it isn't, it's this side divided by that one. So it's the hypotenuse divided by the opposite side. As you can see, I seem to be able to pick the sides before I can actually say their names. In the next video, you'll see that I have another way of thinking of this, where I'm just grabbing the sides I need and thinking about the angle, thinking about the names of the sides later. But anyway, there's your 6 trig functions. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Secant is the hypotenuse over the adjacent, and the cosecant is the hypotenuse over the opposite side. Your 6 trig functions. We will use these so much this quarter. It is imperative that you get so that you don't have to think about what 2 sides you need for each one of these 6 trig functions. The whole course is based on these 6 definitions. Get so that you know them, like you know how to add 2 plus 2, right? In fact, I'll help you out with that. I'll give you an assignment. It's called the 6 trig functions, or the triangle assignment, and then there's a discussion afterwards. Do that assignment, do that discussion, and we probably won't ever have to think about what 2 sides we need.